everything turns opposite. So I'm left with 2x plus 4y is 22 on the top. And when I subtract the bottom, I take away 2x. I take away a negative. When you take away a negative, you're really adding. And I'm taking away another negative, which means again that I'm adding. Well, now I can cancel out my x's. This eliminates. 4 plus 2 is 6y. And 22 plus 8 is 30. So I divide out, and I get y equals 5. So again, because I was not able to just eliminate because they aren't opposite, I need to make one of the x's opposite. So I made the whole bottom row opposite. If you make the x, you have to make the y and the constant. So I subtracted. Taking away a 2x, subtract. Taking away a negative, add. Taking away a negative, add. So that's how I get to this. Now, like we've been doing, we take our y value and plug it back in. Now, if I use the bottom, I use the original equation. I'm just going to use the top. So 2x plus 4 times y, which is 5, is 22. So 2x is 20, or plus 20. So I'm going to take away 20 here. So 2x is left with 2. X equals 1. So let's really quickly check. 2 times 1 is 2. 4 times 5 is 5. 4 times 5 is 20. 2 plus 20 is 22. Good. 2 times 1 is 2. 2 times 5 is 10. 2 take away 10 is negative 8. Correct. So our final answer is 1, 5. That is where these two equations intersect on a graph. Now, sometimes you can eliminate by making one or the other equation a little bit bigger. So I'm only going to multiply one of the equations to make them opposite. Can I make 7 opposite of negative 2? Yeah, I mean, I could, but I have to do something to both equations. But can I make negative 5 opposite of 15? I can by multiplying this to 3. Because watch what happens. If I multiply each piece, I still have negative 2x plus 15y is negative 32 on top. And then when I multiply this out, I get 21x. Take away 15y. Well, what do you notice about the y's? Can we eliminate these? Yes. And then equals 51. So I can eliminate my y's because 15 take away 15 is 0. Poof, gone. Now let's add the rest. Negative 2 plus 21 is 19. So I have 19x equals, should know this, but, 19. 19. So what does x give us? 1. All right, let's plug that into, let's do the top one again. Negative 2 times 1 plus 15y is negative 32. All right, this is a negative 2. So in order to get rid of that, I'm going to add 2 on this side. I'm left with 15y is negative 30. So y is negative 2. Let's quickly check. So when I plug this back in, negative 2, and then this would be negative 30 is negative 32. Then 7 times 1 is 7. Negative 5 times negative 2 is 10. 7 plus 10 is 17. So 1, negative 2 is our final answer. And now I'm going to show you where you eliminate by multiplying both equations. So 3, 4. The smallest number that the two of them can go into is 12. So I could multiply the top by 4, the bottom by 3. I'd have to make one of them negative, though. So we could do that. Or I look at my y's, 2 and 3. Smallest number that they go into is 6. So I think I'm going to eliminate my y's. So I'm going to multiply the top by 3. And I'm going to multiply my bottom by a negative 2 because I need to make them not only the same number, but one has to be positive, one has to be negative. So they have to be opposite. So the top one, 3 times 3x is 9x. 3 times 2y is 6y. And then 3 times 1 is 3. So that gives me my top one. Now when I take my negative 2, 4 times negative 2 is negative 8x. 3 times negative 2 is negative 6y. And then negative 2 times negative 2 is 4. So we make sure, can we eliminate our x's? No. But can we eliminate our y's? Yes. That turns into 0. So then I'm left with 9 take away 8 is just 1x. 3 plus 4 is 7. So x is 7. Now let's put that in. So I'm just going to put it in the top again. 3 times 7 plus 2y is 1. So, 3 times 7 gives me 21 plus 2y is 1. Take away 21. I get 2y is negative 20. So y is negative 10. Let's quickly check. So 3 times 7 is 21. 2 times negative 10 is negative 20. So 21 take away 20 is 1. Correct. 4 times 7 is 28. 3 times negative 10 is negative 30. 28 take away 30 is negative 2. So our answer is 7, negative 10. And again, this solution is telling us where on the graph the two lines intersect. It is showing us what coordinate point makes both equations true. All right, now to show you what it would look like if it was infinitely many or no solution. So this first one, I can't eliminate the x or the y. I'm going to make it easy for me. Just going to multiply the bottom by negative 2 to cancel out my x's. So I have negative 2x, and that'd be minus 6y, and be minus 18. Look what happens. 2x take away 2x is 0. 6y take away 6y, 0. 18 take away 18 is 0. I get 0 equals 0. If you eliminate and everything eliminates out, infinitely many. Now look what it looks like when you have a no solution. Opposite, opposite. I got to make one of them. So let's just make this where I'm going to subtract it. So I'm left with negative 2x plus 5y equals 7 on the top. When I do this, opposite is 2x. Opposite is minus 5y. Opposite is minus 12. Well, look what happens. Cancels, cancels. I'm left with y equal, or 0 equals. But on this side, they don't cancel. That's left with negative 5. Is that a true statement? Nope, 0 is not the same as negative 5, so no solution. So when they eliminate and you get it down to 0 equals 0, or 6 equals 6, or the same thing equals the same thing, or a number equals itself, it's infinitely many. When you get down to something equals something completely different, it is no solution. All right, guys, we are coming to the end. So I want to show you with a word problem how you can use graphing, and then I'm going to show you with a word problem how you can use substitution. So with this one TV service charges $10 per month plus an activation fee of $20. So this would be for one service. So what that is telling me is The TV service is $10 per month, so 10x, plus an activation fee of 20, just meaning that one-time fee. And then it says a second one charges $11 per month plus an activation fee of 15. So the other one is 11 per month plus activation of 15. In what month will they cost the same? All right, so I'm going to graph this first one. I start at 20. I increase $10 each month. So 20 or 30, 40, 50, 60, 70, 80, 90, 100, 110. All right, now this next one, I start at 15 and then I go up 11. So 15, next one would be 26, 37, 48, 59, 60. Oh, I just totally did this wrong. 15 plus 11, 26, 37, 48, 59, 70. All right, so right here is where they match up. So at what month? Well, month 5. So 5 months, they match up at $70. So you're able to write out the equations, graph them, and see where do they intersect. Now a substitution, and you could use it with elimination too. It says a snack bar sells 2 sizes of snack packs. A large snack pack is $5 and a small snack pack is $3. In one day, the snack bar sold 60 packs for a total of $2.20. How many snack packs did they sell? How many small ones? Okay. We're going to have large BX and small BY. So $5 per large plus $3 per the small was sold $220. So what I did with this first equation is I took the amount of money a large one is, and the amount of money the small one is, and how much money we took all together. Now, it says we sold 60 packs. Large snack pack plus small snack pack is 60. So I could actually use substitution or elimination on this one. And what I would do, pause right now, and I want you to actually try it. You choose which method you want, and I want you to try it. All right, I'm actually going to use elimination. So I'm going to make my x's opposite. I'm going to multiply by -5. -5. So this gives me -5x, take away 5y, equals a -300. So my x's eliminate. Put these together, I get -2y and -80. And we just want to know what the small one is, so I'm just trying to figure out my y. When I divide by -2, y equals 40. So in this case, we sold 40 snack packs, small snack packs, which means we sold 20 large ones. All right, guys, so the end of your page or your packet here has a couple of little helpful reviews. So it goes through a visual of what the systems are, where do they intersect. It goes through a visual of how you would do substitution and a visual elimination. So I want you to reflect on how does this tie into your past learning. That could be anywhere from reviewing graphing, reviewing slope-intercept form, reviewing how to substitute in and evaluate problems. Distributive property, we did that in this. So you reflect on how it ties in, and then I want you to summarize the key pieces that go all the way back and review or answer the question, how can I use each method to solve a system of equations? All right.